Speaking of introductions,
Yeah.
here's the thing. A lot of the complexity that you see in high school math really comes down to three basic operations: naming, repetition, and reversal. Naming. So the first point about naming is maybe the most nuanced. The idea is, what exactly is it that we're multiplying or squaring or raising to some crazy power or taking the integral of when we perform all of these relationships or operations on math objects? What are these math objects? Hopefully at some point in your education, you had to go through a process of measuring objects using other objects. And they could be arbitrary. So if you take a piece of paper and you ask, how many paper clips do we need to measure this piece of paper? Or how many pencils do we need to measure this piece of paper? Or how many typewriters? How many water bottles? How many kilometers do we need to measure this paper? Or even, how many lumens do I need to measure this paper? We can kind of see that some units are better suited to certain applications than are other units. And some units just measure the wrong kind of thing entirely. Now, we come across all kinds of math objects as we go along, from natural numbers to watts or inches or euros, or pierogies or inches, feet, lumens, and pogo sticks, and platypi, platypuses, or inches, yards, miles, fractions to variables and constants, sort of unknown quantities, things we're trying to find as opposed to things we already know. But throughout each of these, we're making choices to name them certain things. And I think it's important, as you learn more and more of these throughout your math education, to keep in mind that even at the most basic levels, we had to define what our units are. All math vocabulary really is something that humans invented to make sense of the world. It's not something that we found. Repetition. Once we get into repetition, we see how quickly we can get a lot of complexity from these simple components. So for instance, once we define a unit, repeating that unit is essentially counting. So we say, have one, and then here's another, and that's two, and another, and that's three, and another, and that's four. Repeated counting then becomes adding. Repeated adding becomes multiplication. And then repeated multiplication becomes exponents. So oftentimes students will make errors where they'll conflate, say, raising something to the second power to multiplying by 2. And basically they're just forgetting what level of repetition they're at. Reversals. The other major kind of vocabulary or tool that I want you to think about is reversals. Because oftentimes you can get from one operation to another, either using repetition or using these reversals. So we talked about addition. Reversed addition is subtraction. We talk about multiplication. Reverse multiplication is division. And these kind of inverse functions, we might even call them, or reversals of math operators, are really important when it comes to solving algebra problems. Frequently, there's sort of like a building up of that relationship and then an undoing of it. Multiplying by 2, dividing by 2. Adding 3, subtracting 3. Cubing something, taking the cube root of it. Seeing these symmetries will really help you connect ideas between your math classes from unit to unit and year to year. You're looking for a closing line here?
I'm fine.
You were trying to be quiet, but it was very demonstrative. Quietness. It was like, hey, look at me not taking attention when I take this coffee.